Hello everyone and welcome to a new lecture, correlation. So correlation is any of a broad class of statistical relationships involving dependence, though in common usage it most often refers to the extent to which two variables have a linear relationship with each other. Familiar examples of dependent phenomena include the correlation between the physical statures of parents and their offspring, and the correlation between the demand for a product and its price. Basically, correlation measures how closely two variables move in the same direction. Tall parents have tall kids, highly correlated. Wear a lucky hat but rarely win at cards, very slightly correlated. As your standard of living goes up, your level of savings plummet, highly negatively correlated. Simple, right? Well, computing correlation can be a little difficult by hand, but is totally simple in Python. Now let's run a correlation. Okay. Okay, so we have this data and we have to copy this down. But now we will write df.core, which is correlation function. Okay, so we have this. So the intersections with the highest absolute values are the columns that are the most correlated. Positive values are positively correlated, which means they go up together. Negative values are negatively correlated. As one goes up, the other goes down. And of course, each column is perfectly correlated with itself. As you can see, hours of study and grade are highly correlated. Now it's your turn. Load the data from the sample I'm giving you here and find the correlations. Okay. Wait, let me add. It goes up. It's gonna renamed as your turn. Your turn. Now Miami. Gonna save this file. Gonna load this file as TA Miami. Okay, so now let's move on to a new lecture, regression.